In the video today, we're going to do some more equivalent capacitor problems, and let's take a look at this setup. Now in this setup, they're telling us that each capacitor is 5 microfarads. So we have to decide, well, how are we going to do this? What I would do is do it step by step. Let's just look at these two. Now, these two capacitors are in parallel. Since they're in parallel, it's easy enough to add them up. That's 10 microfarads. So what we're doing is we're saying, can we combine any of these and make our lives easier? And we can. We can just think about this as it would be the same, instead of having two 5 microfarads, it would be the same as having one 10 microfarad plate. Now we can't forget about that one there to the right, the 5 microfarads. So you can think about it, I took these two and collapsed it. I tried to simplify it. I said, let's imagine or pretend they were just a single 10 microfarad plate. Now to get the equivalent capacitance, we see that this plate and this plate are in series. Series is one after the other, like watching it. You watch each episode of a television series in order. Or read each book in a series like Harry Potter, you read them in order. And it's a fraction, unfortunately. So we're going to have to add a tenth to a fifth, which is 2/10. So that's 3 over 10. I could do it in a calculator if I wanted, but it's easy enough to do that. Now we have to do the reciprocal. And 10 over 3 is 3.33 microfarads. So what does all that mean? What that means is, instead of using these 3 individual ones, we could put in one 3.33 microfarad capacitor. You might say, well, why do that? Why not just do that? Sometimes you need a particular specific capacitance for a particular circuit. And they don't always make them that way. For example, they probably don't make a 3.33 microfarad capacitor. I'm sure they make 5 microfarads. So sometimes you have to be a little bit clever and say, okay, what can I buy off the shelf and how can I arrange them to get what I really want? Now here's another one. It's a very similar problem, but it doesn't hurt us to do a second one. I've got a 3 microfarad, a 5 microfarad, and a 1 microfarad. But these two are in parallel of each other. They're across from each other. So the nice thing about that is I can just add them. 5 plus 1 is 6 microfarads. So what that means is it's the same thing as if I had a 3 microfarad capacitor in series with a 6 microfarad capacitor. These two just combine. If we took them out, we could just, if I cross all that out, put a 6 microfarad capacitor in there. I know it's real sloppy, but I hope it shows you what's going on. Now, these capacitors would be, just like we saw in the last problem, they'll be in series. So in series, you have to add them up that way. Let's see, that's 2/6, so that's 3/6. Taking a reciprocal, just like we did before, should get us 2 microfarads. And I'll double check that on my number machine here, just because I don't want to trust my fractions. I should, but yeah. And it's a 2 microfarad capacitor. Okay, let's see if we have any more complicated ones. Yeah, let's try this one. This one looks a little more fun. So we want the equivalent capacitance here. Now, I should have pointed this out maybe in other videos. Sometimes they show you with these dots, and they have the volts in here. What these dots mean is you could take this whole thing and put it in any circuit. But we're going to have a voltage change or voltage drop of 24 volts. And we'll talk more about voltage drops next chapter. So this looks more scary because there's 4 plates. Let's not let it scare us. Those two are in parallel. So when they're in parallel, we can simply add them up. 3 microfarads plus 4 microfarads to get us an equivalent capacitance of 7. And what that now means is, if I redraw the circuit, we didn't do anything with the 1 microfarad capacitor. We didn't do anything with the 2 microfarad capacitor. But now instead of a 3 and a 4, we've got a 7 microfarad capacitor. And all these are in series. It means they'd have the same charge on them. So 1 over C equivalence is 1 over 1 plus 1 over 2 plus 1 over 7. And I'm certainly going to let the calculator do that here. So 1 plus 0.5 plus 1 divided by 7 is 1.64. That's what that works out to. Now to get the C equivalence, I've got to take a reciprocal, and it works out to, yeah, good, I got the right number, 0.609 microfarads. So, one more and we're going to be done for today. Let's see. Now, these two here are in series. But what we can do is we can still work with that. You say, well, I don't want to touch that one yet. Okay, 6-volt battery. We'll deal with that later. So because they're in series, I have to use the fraction. And I'm going to let the calculator do that. 1 divided by 10 plus 1 divided by 3. And that 0.433. So the equivalent capacitance, take a reciprocal, don't forget take a reciprocal, is 2.31. But now I've got to see, well, what does the drawing look like? I've got a 5 microfarad and a 2.31 microfarad. Those are in parallel. So the equivalent capacitance is just 5 plus 2.31, or 7.31 microfarads. And we're done.